Hi guys, so today we'll be doing differentiation from first principle. So when they speak about differentiation, they say the differentiation is a process of determining the derivative of a given function. So meaning you'll have to be determining the derivative of a given function, meaning you'll be given a function and then you'll be asked to determine the derivative of a function which is given using the first principle method. So you know that when we speak about a function in mathematics, we're speaking about something like f at x equals to, maybe let's say, x squared. So this is the function. So they might say determine the derivative of function f at x equals to x squared using first principle. So how do you determine a function, a derivative using first principles? So there is a formula for first principles which says f at x is equals to limit when h approaches 0, then f at x plus h minus f at x, this is your original function, all this divided by x. So this is the formula for first principles. This is the formula which you use to find the derivative of a given function using first principles. So let's go and do one example. Let's say you are given function f at x equals to 2x minus 3, and they say determine the derivative of this function using the first principles. If they just said to you determine the derivative of this function and they didn't say anything about first principles, you know that to determine the derivative of this function, it was going to give you since 2 it's 2x and the x does not have any exponent, so we know that it's 1. So therefore the derivative of 2x is going to be 2, and then there we know since we have a constant, then the derivative of constant, it was going to be 0. Therefore the final answer there, it was going to be 2. So this has to be the same also when we use the first principle. So let's go and do that using the first principle. So I just want you guys to know the first thing that you should do when you use the first principles. So first thing that you have to do, write down the first principle formula, which is the one that you wrote there. And then the second step, you have to determine your f at x plus h, and also determine your f at x. Because remember, this is what your formula wants. Your formula wants f at x plus h, and your formula wants f at x. So for f at x plus h, what you have to do, guys, this is so simple. So if you can see, you have your equation there, which is your original equation. So what you have to do, you just have to go in your equation, and everywhere where you see x, you are going to replace your x with x plus h. So let's go to our original equation. We have 2x, so we just go in there, open brackets, and replace our x with x plus h. And then on the second term is just 3, so it's just negative 3, sorry, so we don't have x there, so we're not going to replace it with anything. And then our f at x, obviously we know it that it's our original function, so I will just remove this here. And then after finding or determining the f at x and f at x plus h, that's when now we can proceed to our formula and just substitute our values that we have. So f at x is equals to limit when h approaches 0, and then you know that on f at x there we have 2 open brackets x plus h minus 3, and then there we have minus, and then you just to be on the safe side, just come and open a bracket so that you know this minus is going to multiply everything inside the bracket just to avoid any mistake. So therefore we're going to have f at x there, which is 2x minus 3, then close brackets there, and then all these guys is divided by h. So therefore, let's go and simplify our equation. F at x is equals to limit when h approaches 0, and then we're going to have this 2 is going to multiply everything inside that bracket. So let's go and do that. 2 times x is going to give us 2x. You know that this is just these guys. And then 2 times h, it's going to give us plus 2h. So we just expanded those brackets there, and then we have minus 3 there. And then here, let's just multiply everything inside this bracket with the negative. So negative times 2x is going to give you negative 2x, and negative times negative 3 is going to give you plus 3, guys. So yes, and then you're going to have all these divided by h. And then the third step, we're just going to add or subtract the like terms from our numerator. So if you can see, just want to change the color to make it red. If you can see there, we have a 2x, which is minusing with that 2x there, so it's going to give us 0, that one. And then we have minus 3 plus 3, which is going to give us 0. So therefore, on the numerator, we'll be left with 2h divided by h. You see, guys, and therefore now if you can see, h is dividing with h there, therefore these can cancel each other, and we are now left with f at x equating, since now we don't have h anymore, our h has approached the 0. So therefore we don't need to write f at x is equals to limit when h approaches 0. We're just going to write our final answer as f at x is equals to 2, which is the same answer that we got when we derivated this equation without using first principle. Thank you very much, guys.